G'day. Do you ever like to ask what if? Well, in mathematics we do that a lot, and since I've been following this series about graphing, and particularly graphing asymptotes, I'm going to ask a what if. What if we had something like y minus 2, y plus 3. So they're two horizontal asymptotes. And I create two vertical asymptotes, x minus 4 and x plus 5. So far so good. Let's graph them. One, two, three, four, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Good. Vertical asymptotes. There's one at plus 4. And there's one at negative 5. So far so good. We have two vertical asymptotes. One at y equals 2. And one at y equals negative 3. Now, if you've just suddenly discovered this video and you haven't been watching the series, this will probably be confusing to you. I do encourage you to go back and look at previous videos. There's a playlist in YouTube which I've created to deal with polynomials and with hyperbole and asymptotes, and this is just part of an ongoing series where I explain principles. But so far these give us vertical asymptotes and horizontal asymptotes, and we've now divided the graph into 9 regions, a bit like a tic-tac-toe or a noughts and crosses board. The simple graphs have a constant up here, like a 5 or a 7, or even a negative constant like minus 3. The more complicated ones have an expression. I'm just going to put x. And this expression changes its value as x changes. So sometimes it will be positive and sometimes it'll be negative. And what it means here, well actually let's put x plus 1, because that means at negative 1 something is going to happen. Because minus 1 plus 1 makes a 0, and when that is 0, then I have these two factors equal to 0, and it means that y would be worth 2 or y would be worth negative 3, and it means that the graph will go through minus 1, 2 or minus 1, minus 3. So in fact it will actually touch the asymptotes. Not just touch them, it will actually do something quite startling and cross them. And that's worth knowing and understanding what this does. Now, I showed you in the last video, if you watched it, a case where we had a number. We stacked, I think it was 4 horizontal asymptotes. So it cut at 4 places, and we had a curve just zigzag its way up. Here's a what if. What if, instead of just having something happen when a changeover when x is worth minus 1, what if we had a changeover when y had a value? So what if we put a factor here with y? Let's make it equal, let's put it on the x, we'll put it on the x-axis. There we go, just y. So when y is 0, we've got a similar issue takes place. Now we could imagine these terms up here. So when y is 0, x equals 4 or negative 5 becomes an issue, and a changeover occurs at these two positions. Now the graph becomes interesting, and I encourage you to check this out on Wolfram Alpha. just Google that site and go to it. You can type the formula in and see the graph. It struggles to show these graphs, but goes to show that sometimes the brain is better than the computer still. Let's see what happens. Since we have positive coefficients for everything inside, and this is positive on the top, the graph is going to start in the top right hand corner. So just like an hyperbola, it will start up here. That's not meant to touch the asymptote, by the way. There we go. Now, the graph will expect to continue diagonally across these two normal asymptotes. Like so. I shouldn't put an arrow on. I'll wait for it to dry. But something happens. When it gets to this point, it crosses over the asymptote and continues up there. I'm having trouble with the board and the asymptote. The board bounces as I draw, so it's proving a bit interesting. And when it comes down, this time it's going to cross this asymptote and want to continue. So now we've suddenly got a zigzag effect. That's something I'm quite confident you've not seen in school. Now, the corresponding part, we can look at it in different ways. Here we have two normal asymptotes, and we're going to have part of the graph diagonally across, and it's going to cross up through here. Another way is to understand, yeah, well, that's probably the better way. I won't go with further explanations. It'll cross over and want to do this, and then it's going to cross over and want to come out along that asymptote, and diagonally across these two asymptotes, this cross here, it's going to appear like so. Now that is different. This all came out of a what if. What if we had, instead of just x in here, what if we had a factor with y up in the top? Now if we had a factor with y in the bottom, we would just simply multiply it and move it up with these. That's not difficult. But with the y up here, where it can also change the value of the sign of the numerator, then we start to get some very, very interesting patterns take place. Now you can appreciate that if we doubled asymptotes, so things reflected, or if we had oblique asymptotes, things can get quite complicated. But the principles are there nonetheless. That these expressions up here give us points where the curve crosses the asymptotes and goes into the next region to complete its mission. I hope you've enjoyed that. I want you to explore it. Write up your own equations with different factors and things. Experiment with these here. Type it, go to Wolfram Alpha and type the equations in and try to draw them yourself first, and then see if Wolfram Alpha comes up with the same graph. You're not going to get these in your exams, but the principles you will learn in doing them will help you become very good at graphing. And that's my aim. So I hope you've enjoyed it. Please, if you've liked the video, please click the like button. Of course, I'd love you to leave a comment. I enjoy receiving them. I always reply to them. And if you're not a subscriber, please subscribe. I look forward to showing you other videos. This is, by the way, the last in this particular series, unless I have some other inspiration or some person contacts me for something new. I think we've pretty well exhausted the kinds of questions you're going to get in school. As always, I thank you for watching.